Hi, welcome to our 12th week of distance learning. This week we are going to be reviewing the shapes we have been talking about up to this point, as well as diving a little bit deeper into circles. So let's start with quadrilaterals. Here's a quadrilateral. In fact, every single shape on here is a quadrilateral because it has 4 sides. Now, let's talk about the parallelograms and the trapezoids. Those are our two big sections. Parallelograms have 2 pairs of parallel sides, and we have already talked about this. Parallelograms have the top and the bottom that are parallel. That means they never cross. They go in the same path forever, as well as the left and right. Trapezoids, on the other hand, here's 2 types of trapezoids. They have 1 pair of parallel sides. So you can see here the top and the bottom are parallel. Those little arrows tell you they're moving in the same direction, as well as here, parallel sides. Now trapezoids could be isosceles. They could have 2 of the non-bases that are parallel, or they could be even a right trapezoid. There's many different kinds, but the important thing is that they have exactly one set of parallel sides. Let's head over to the side with the parallelograms because there's a lot of different kinds of parallelograms you may have not noticed are parallelograms. For example, a rhombus. A rhombus has 4 congruent sides, and we know those little marks right here mean that the sides are congruent. So if one side is 5, they are 5 all around. We do not really care about the angles in a rhombus, just that the sides are congruent. As it turns out, the angles on the top and the bottom are going to be congruent, as well as the angles on the left and the right. Now, what about rectangles? Rectangles, we know very well. We've talked about them quite a bit. They have 4 right angles. And right angles means that they have 4 angles that measure 90 degrees each. Now let's talk about squares. Squares are very special because squares have 4 congruent sides. So if this side is 5, 5, 5, 5 all around. And they also have 4 right angles, 90, 90, 90, and 90. Here's what squares look like. 4 congruent sides and 4 right angles, which means that squares are parallelograms. Yes, squares have 2 sets of parallel sides. So do rectangles, so do rhombi. They also have 4 congruent sides, which means that squares are a special type of rhombus. But, on the other hand, they also have 4 right angles, which means squares are a special type of rectangle. Squares are everything. They hang out with everybody. They are parallelograms, they are rhombuses, they are rectangles. They are everything. I hope this was helpful to clarify all those questions you've been having about what it means to be a certain figure, a trapezoid, a parallelogram, and why are rectangles and squares so similar, what's going on. Now let's move on into circles. Let's dive beyond radius and diameter. You know that really well, but now we can start talking about arcs and sectors and all these other wonderful things that you may or may not have learned about. If this is review for you, that's wonderful, but I think for the majority of us, this is our first time seeing this topic. Don't forget to send me your notes at the end of this video, and please, please, please ask questions if you have them. I'm here for you. Text, call, email. Bye! We have 3 pizzas, a small that is 10 inches, a medium that is 12, and a large that is 14. The question is, would you prefer 1 slice of large pizza or 2 slices of small pizza? Let's figure out how much area there is in 1 slice of large pizza. If we take a 14-inch pizza, what they're telling us is that the diameter is 14 and the radius is 7. And normally, we divide a pizza into 8 different pieces. Hopefully 8 equal pieces, otherwise that's really annoying. Now, let's take a look at the 1 slice that we want. We're going to take out this slice, and that is now called a sector. A part of the full pizza is called a sector, and this sector has a radius of 7 inches. So let's take a look at what information we know. We know we are looking at slices, and we know we are looking at area. We want 1 out of 8 slices total, but what is the area of my slice? That I don't know. However, I can find the area of my full circle. Area equals pi r squared. and r is 7, so pi times 7 square, which is 49 pi square inches in this case. I am going to write x over 49 pi, the area I don't know of my sector, and the whole pizza. 1 times 49 pi is 49 pi, while x times 8 is 8x. To leave x alone, I have to divide by 8 on both sides, and when I put this into my calculator, I get 19.24 square inches. Now let's consider two slices of a 10-inch pizza. The diameter is 10, which means that the radius, or the length of my slices, is 5 inches. Each radius is 5 inches. Now to find my proportion, I know I need 2 slices, so I'm going to cut this pizza into 8 equal pieces and write 2 over 8. 2 slices out of the 8 total. Now I don't know the area of my sector of my 2 slices, but I do know that the area of my full circle is pi r square and r is 5. So 5 square is 5 times 5, which is 25 pi. Remember, if you would like to multiply 25 by 3.14, you may do so. I prefer to leave it as an exact answer. Now to multiply 2 times 25, I get 50 pi, and 8 times x is 8x. I divide again by 8 and I get 50 pi divided by 8, which is 19.63 square inches. So back to our debate. What do you prefer? 2 small slices of 10-inch pizza or 1 large slice of a 14-inch pizza? The 2 slices of a small pizza will get you 19.63 square inches, whereas 1 slice of the large pizza will get you 19.24 square inches. So if you want more pizza, you're better off going with the small rather than the large. When we are talking about sectors, we are talking about the shaded regions, the part of the circle we want to know the area of. In this case, we have a circle with radius 7 centimeters, and we want to find out an area with 100 degrees. So we don't know that area, but we do know the area of the full circle, which is pi r square, with r being 7. So this should look very familiar to the pizza problem we just did. Our area is 49 square centimeters. So I am going to write 49 pi. Remember, you can multiply it if you would like, but I like my exact answer. Now, because I don't know how many slices, I am going to use degrees, and I am going to write 100 degrees. You don't need the symbol, it's like having the units, but you can if you'd like, divided by 360 degrees total, because there are 360 degrees in a full circle. 100 degrees is the region I want, and 260 is what's left over. 100 times 49 pi is 4,900 pi. And if you're wondering how I did that, I think of 100 times 49 as 1 times 49 is 49, and then add the 2 zeros. Or I can think of 100 as 10 square, and using scientific notation, I can move my decimal point 2 zeros over. So 4,900 pi equals 360x. I divide by 360 this time because my full circle is 360 degrees. And when I put 4,900 pi divided by 360 in my calculator, I get 42.8. And I wrote square inches, but it should be square centimeters. I have rounded to my nearest tenth. You can round differently. Let's talk about arcs now. Arcs are sort of like sectors. Sectors are the area, whereas arcs are the perimeter. They are the outside of the circle. Let's think of the circumference and its formula rather than the area and its formula. We're thinking about the outside. To find the outside, we're going to do the same process. We are going to create a proportion, and we're going to say we have 60 degrees out of 360 total. I don't know the length of my arc. Notice I'm not asking about area, I am asking about length. But I do know the length of the circumference all around. That is 2 pi r, where r is 15, because my radius is given us 15. 2 times 15 is 30, So my circumference is 30 pi. And now I can say, well, 60 times 30 is 1,800 pi, and that is equal to 360x. I divide by 360 on both sides to isolate my variable, and when I put this into my calculator, I get 1,800 pi divided by 360, or 180 pi divided by 36, which is 15.7 units. Finally, let's take a look at an arc and a sector of the same circle. First, let's find the arc. When we talk about the arc, we talk about the length, and we are going to say we have 150 degrees out of 360 total. Now, I don't know the circumference of this arc, I don't know the length of this arc, but I can find the circumference of my full circle. Using the formula, circumference equals 2 pi r, where r is 10. 2 times 10 is 20, so I have 20 pi. And this is in inches, not square inches, because perimeter is only one dimension. Now, 150 times 20 is 15 times 2, which is 30, and I add the 2 zeros and put the pi right behind, and then multiply 360x. 360 gets divided on both sides, and that gives me 26.2 inches. This is rounded to the nearest 10. 26.2 inches is the length of my arc. Now let's find the sector. My sector also uses 150 over 360 degrees because that's how much of the circle we have. But now we want to know what is the area of the full circle, because if I want to know the area of my circle, I need to be able to know the area of the whole thing. Pi times r squared is pi times 10 squared, or 100 pi. And when I multiply 150 times 100 pi, I get 1 times 15, which is 15, and include the 3 zeros and times pi. Then I multiply x times 360, which is 360x, and divide by 360 on both sides. 360 is always a constant number because 360 is the number of degrees inside a circle. When I put 15,000 pi divided by 360 into my calculator, I get 130.9 square inches. And now you can solve for arcs and sectors all by yourself.